5.6, the fundamental theorem of algebra. So, very important, and you're going to see, I'll show you on the next slide what it means mathematically and what it shows, but here's basically what the fundamental theorem of algebra states. If you have a second degree polynomial, then you're responsible to find two zeros or roots. If you have a third degree polynomial, you're responsible to find three. If you have a fourth degree, responsible to find four, fifth degree, responsible to find five, so on and so forth. So basically, and we've learned through the last three sections that there are certain cases where we have multiplicity of zeros, and that's when a graph bounces off of the x-axis, so that would be counted as more than one zero. We have our complex root theorem, so if I'm given one imaginary zero, I'm automatically given two. So I like to ask a question, can you have, for a cubic polynomial, can you have three imaginary zeros? And the answer to that is no, because if you have one, you automatically have two. If you have three, then you automatically have four, and that would give you four zeros, and a third degree polynomial would only have three zeros. So you could have two imaginary zeros and one real, which means that you will see it cross the x-axis, or you could have all three real zeros, but you can't have three imaginary zeros for a cubic polynomial. It has to cross the x-axis. Okay, so again, here's kind of a picture of it, where this one you clearly see there's two zeros. This one, it bounces off the x-axis, so it would have only one that it shows, but it counts as a repeated zero, so both of the zeros would be right here at 1, and then here's a parabola that has no real zeros. Both of those would be imaginary, and we have to find imaginary zeros by using the quadratic formula or by factoring. So that's how we're going to be solving these. And I'm going to ask you to basically prove or show that all these zeros are zeros. We're going to use Desmos. We're going to use the quadratic formula. We're going to use factoring cheats, things that we've used throughout the last couple of chapters to be able to solve these. So this kind of just shows where the two real zeros are and where those parabolas were from this last page. This was x squared minus 4. We see the zeros are 2 and negative 2. This has one real zero, which we see is at 1, and again, that would be multiplicity, 2, because it has to have two zeros because it's a second degree, and then this one here would be two complex roots, which we would get from using the quadratic formula. So here's the mathematical way of saying the fundamental theorem of algebra. If p of x is a polynomial of degree n greater than 1, which means it's a second degree, third degree, fourth degree, or linear, then p of x equals 0 has exactly n roots. So if it's a fifth degree, it has exactly 5 roots, and that's including multiple and complex roots. So again, you're responsible to find the number of the highest degree of roots. So what are the roots of this problem? And here's how we can do this. Okay, first of all, I have to type this into Desmos, or a graphing calculator. So the first thing I'm going to do is plug this into Desmos, and I want to make sure that you type it in correctly, x to the fifth, and what I'm looking for is where does this thing cross the x-axis? Okay. Where does this cross the x-axis? So minus 3x cubed. It was plus 3x squared. I'm going to double check that. Minus 4x plus 4. So, unfortunately, I can't trust this graph in saying that negative 2, 1, and 2 are all of the zeros, and bam, I'm done. I'm going to have to prove that those are zeros, okay? And again, I got this just by plugging it in. And now, how many zeros am I responsible for? The fundamental theorem of algebra tells me that I have to find 5 zeros here, okay? So what are the zeros that I think from the graphing calculator would be negative 2, 1, and 2? Okay, so negative 2, 1, and 2. These are from Desmos, where it crosses the x-axis. I'm going to show that by doing synthetic division. Okay, so I'm going to do synthetic division, and I'm going to repeat the synthetic division until I get a remainder of 0. So I drop the 1, multiply, add down, multiply, add down, multiply, add down, multiply, add down, and I do get a remainder of 0. So that proves that -2 is in fact a 0. Now, I'm not going to rewrite it the whole problem. I'm going to work this down. I'm going to do multiple synthetic divisions using the given zeros, okay? So again, I'm going to drop the first term. I multiply, I add down. I multiply, I add down. Multiply, add down. Multiply, bam. I got 0 again, which proves that 1 and -2 are zeros. Where did I get these values from? That's where the graph crossed the x-axis. Okay, I'm going to do synthetic division again. Drop the 1, multiply, add, bam. I got a remainder of 0 again. So now I have no more zeros to try. I have just proven that -2, 1, and 2 are zeros. Okay, what am I left with here? I'm left with my remainder, my constant, my x, and my x squared. So I'm left with x squared plus 1 equals 0. I am responsible to find the two zeros from this. Okay, if we remember back to 4.8 in complex numbers and factoring, I factored this to x plus I, x minus I, okay, because this is the sum of two squares. So this, using the zero product property, would be -I, positive I. The 5 zeros would be -2, 1, 2, -I, and positive I. And again, if you don't remember how to do that, okay, I was left with, again, a 1x squared. I don't put 0x plus 1. If I don't remember that, then I had x squared plus 1 equals 0. I would have to do the quadratic formula, which is the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So again, look at this. A is equal to 1. That's from this coefficient. B is equal to 0 because there's no x term, and c is equal to 1. So then I would go through, and obviously you can't have -0. I can't plus or minus anything, so I've got 0 in underneath the square root would be -4 over 2. Well, what's the square root of -4? Okay, well, remember, rewrite this as square root of -1, square root of 4. So that would be plus or minus 2i over 2, which is plus or minus I. That is where I got those values from here. If I asked you to write out every single factor, okay, again, if I give you a 0, we proved this was a 0. I put an x in front. I change the sign. I put an x in front. I change the sign. I put an x in front. I change the sign. And then you could write it as x plus I, x minus I, or x squared plus 1. Okay, so this is asking for all of the roots. All of the roots are -2, 1, 2. What was the mathematical proof? Getting a remainder of 0. And then -I and positive I, mathematical proof was either by factoring or what I did here, which was the quadratic formula. Okay, so let's take a look at another example. In order for me to solve this, I have to make sure that it's set equal to 0. So the first thing that I need to do for this problem is subtract 13x squared and add 10x to both sides. Okay, so I've got x to the 4th plus 2x cubed minus 13x plus 10, that's x squared, plus 10x equals 0. So I should be able to ask you right now, how many zeros should you be able to find? And the answer to that is 4. So I'm going to go to Desmos. I'm going to plug this in, okay? X to the 4th. Again, I'm trying to find where it crosses the x-axis. Trying to find where it crosses the x-axis. Plus 2x cubed minus 13x squared. Where are you at? Minus 13x squared. Just making sure that I don't screw up what I'm typing in. Plus 10x. Okay, again, had to set it equal to 0 first. Now, I should be able to find 4 zeros. And because I see 4 zeros, this indeed does have 4 real zeros at negative 5, 0, 1, and 2. Okay, so I get these zeros. Now to show the mathematical proof, negative 5, 0, 1, and 2. And again, that came from Desmos where it crossed the x-axis. I'm going to do synthetic division. And I get 1, 2, negative 13, 10, and then 0. Remember, there's no constant term here, so I'm going to put that out there. I'm going to test negative 5 first. Drop the 1, and then I do the synthetic division. It works, okay? And again, I'm going to do it again. So I'm going to try 0. Drop the 1, 0, negative 3, 0, 2, 0, 0. Bam, it works. Now look what I'm left with. I've just proven that negative 5 and 0 are indeed zeros and roots. What am I left with? This is, again, my remainder, my constant, my x squared. So I'm left with x squared minus 3x plus 2. This is a quadratic that you're able to factor, okay? So I could factor this to x minus 2, x minus 1, right? Two numbers that multiply to 2 and add to 3. And then using the zero product property, I get 2 and 1 are my other zeros. So I proved that negative 5 and that 0 are indeed zeros by doing synthetic division and getting a remainder of 0. And then I proved that 2 and 1 were zeros by factoring it and doing the zero product property. Okay, you can also continue to do synthetic division again. If you're more comfortable doing synthetic division and showing you get a remainder of 0, then you're more than welcome to do that. So I could also have just kept doing synthetic division. 1, drop the first term, negative 2, 0. Bam, that proves it. Again, I can do it again. Put a 2 here, drop the 1, 2, 0, done. So you can prove this all the way through doing synthetic division and getting remainders of 0, or you can do this by getting it down to a quadratic and factoring it. You will have to do the quadratic if it has imaginary zeros, okay? If it has imaginary zeros, we have to do synthetic division. So I'm going to look at this problem right here. I'm going to get rid of this one here. Okay, so let's take a look at this problem right here. And let's go to Desmos and plug this in. Okay, so 2x to the 4th. Let's see if I can do this. There we go. That's a little easier. 2x to the 4th. Minus 3x cubed. Minus x minus 6. Okay, so I know I'm responsible to be able to find 4, but I only see 2 here, which are negative 1 and positive 2. So I'm going to have to work this 4th degree polynomial down to a quadratic and then do the quadratic formula or be able to factor it. So again, it crossed at negative 1 and 2. Again, this came from Desmos. Negative 1. Where'd you go here? Let's go back to that. There we go. Negative 1 and 2 from Desmos. So I've got 2, negative 3. Make sure every term is accounted for. Since it skips x squared, I have to put a 0. Negative 1, negative 6. Again, make sure you know where that 0 comes from. That's because there is no x squared term. So it doesn't matter which number I start with out here. I'm going to put the negative 1. And again, I got that negative 1 from Desmos. Okay. So again, I should get a remainder of 0 here. And I do. So bam, that helps me. Now, how come I don't write this out as a polynomial? Because this started off as a fourth degree. When I break it down, that's a remainder constant x squared, x cubed. I don't know how to solve every x cubed. I do know how to solve every quadratic. So I'm going to work this down to a quadratic. And that works. So now I'm left with a 2x squared minus x plus 3. Now, you will not be able to factor this, and how I know we can't factor it is because it doesn't cross the x-axis. I'm going to get imaginary zeros here, so I have to do the quadratic formula, okay? Back from chapter 4. So I have the opposite of b, plus or minus the square root of b squared, which is negative 1 squared minus 4 times a, which is 2, times c, which is 3, all over 2a. Again, I'm not going to put 2a, sorry, times 2 times 2. Okay, so again, 1 plus or minus, I'm going to leave a blank square root. What am I going to put into that blank square root? Everything here. Okay, negative 1 squared, and use parentheses here, negative 1 squared, okay, minus 4 times whatever a was. So a was 2 and c was 3. Okay, so 2 times 3. This is the number I put underneath the square root, negative 23. So I'm going to put a negative 23 underneath the radical. Again, you can't do this just by using a calculator, all over 4. So 23 is a prime number. I can't simplify that other than being able to take out an I. So my zeros are 1 plus I square root of 23 over 4 and 1 minus I square root of 23 over 4. Fourth degree polynomial, 1, 2, 3, 4 zeros. Okay. Again, it's just much more of the same. When you look at a graph, what do you know, okay, about this graph? Well, what are the zeros? I know that there's at least 2, okay, and then don't forget multiplicity. So here's some other things that you can look at. But again, a lot of the homework is doing synthetic division and finding zeros. I'm gonna put another video up just of a couple of examples from Delta Math to look at the types of problems you're going to be asked to do. But the key to this section is if it's a fifth degree polynomial, you have to find 5 zeros, which means you're going to find 3 real and be able to simplify and do the quadratic formula with what you're left with after doing synthetic division.